Volcanoes are incredible. They build mountains, create islands, and they even release the gases that helped form our atmosphere. But what if we took all those amazing things volcanoes do and cranked them up to 11? What if every volcano on Earth erupted at the same time? How much destruction could our planet actually withstand before it was, well, earthquaked out of existence? Let's take a deep dive into this fiery topic. But first, if you're not already subscribed, please do so now. It's free, and as a thank you for your support, here's a fun fact. Most volcanoes aren't explosive at all. Instead, they ooze lava that flows like really thick honey. Volcanoes happen when rocks deep in the earth melt and turn into magma. That magma is less dense than the solid rock around it, so it rises toward the surface. As it pushes against the crust, the rock can buckle and bend, eventually creating a mountain-like structure. When the pressure is great enough to break through the crust, molten rock, ash, and gases escape in a spectacular eruption. When a volcano erupts, it releases gases that have been trapped inside the earth for millions of years. Some of these gases, like carbon dioxide, have been responsible for most of the changes in Earth's climate throughout history. In fact, volcanic eruptions are the reason why there is a theory that COVID-19 came from a bat-borne virus. The culprit was an increase in carbon dioxide caused by Mount Shinmo-dake in Japan erupting. The CO2 caused global temperatures to plummet, and bats were forced closer to humans in search of warmer climates. And thus, we were introduced to SARS-CoV-2. Other volcanic gases, such as sulfur dioxide, can reflect sunlight and lower global temperatures for several years. For example, after the 1815 eruption of Mount Tambora in Indonesia, temperatures dropped between 2 and 7 degrees Celsius below normal for 7 years. There was even snow in India during the summer. So if lots of volcanoes erupted at once, the sky could fill with ash, blocking sunlight and cooling the whole planet. How cool would that be? Unfortunately, probably not cool enough to counteract the damage done by a worldwide volcanic eruption. Plants would die without sunlight, leading to global food shortages and the collapse of the entire ecosystem. So let's hope it never happens. If Mount Everest were made of cheese, then every volcano on Earth would be its mouse hole. About 40% of volcanoes are dormant, meaning they haven't erupted in thousands of years, but could erupt again in the future. An estimated 15% are active, having erupted in the past 10,000 years and expected to erupt again sometime soon. And finally, 5% are considered to be potentially active. These volcanoes haven't erupted in the last 10,000 years, but scientists think they might in the next few hundred. The largest volcano in the world is Tamu Massif, located in the Shotski Rise region of the Northwest Pacific Ocean. Its most recent eruption was around 140 million years ago. It has since gone dormant. At its base, the volcano is about 62 miles wide, which is wider than 18 American football fields lined up side by side. Its total volume is approximately 1,600 cubic miles. That's roughly equivalent to 640 American football fields stacked end to end. This enormous volcano contains a summit caldera over 25 miles across, formed after the collapse of the volcano's upper mass. The summit caldera is so large that if Mount Everest were placed within it, it would disappear from sight. So while Tamu Massif isn't currently active, the sheer size of the volcano means that if it did erupt, the consequences would be devastating. Don't worry, it's not about to erupt anytime soon. In order to get a rough estimate of what would happen if every volcano on Earth erupted, we need to consider the potential impact of the most dangerous types of volcanic eruptions. Volcanic eruptions are categorized based on their severity. The Volcanic Explosivity Index, or VEI, is a scale used to describe the magnitude of volcanic eruptions. It considers factors such as the height of the eruption column, the volume of material ejected, and the duration of the eruption. On the VEI scale, a level 8 eruption is the most violent type of volcanic eruption. Level 8 eruptions are incredibly rare. The most recent one that we know of occurred in 1815, when Mount Tambora erupted in Indonesia. This was the largest eruption in recorded human history. Level 7 eruptions are also quite rare. An example of a level 7 eruption is the Novarupta eruption in Alaska in 1912. These two types of eruptions are known as cataclysmic eruptions because they can cause significant devastation over large areas. In terms of frequency, Level 7 eruptions occur roughly every 100 to 200 years, while Level 8 eruptions happen only about once every 1,000 years or so. Now let's calculate the consequences of multiple simultaneous Level 7 and 8 eruptions. We'll assume that 50 Level 8 eruptions and 500 Level 7 eruptions occur simultaneously. Level 8 eruptions eject between 1,000 and 10 billion cubic feet of material. Medium Level 8 eruption ejects around 100 million cubic feet of material. Let's use this figure as our baseline for this scenario. Multiplying this number by 50 gives us a total ejected material of 5 billion cubic feet for all Level 8 eruptions combined. Level 7 eruptions eject between 100 million and 1 billion cubic feet of material. A medium Level 7 eruption ejects around 1 billion cubic feet of material, which multiplying this by 500 gives us a total of 500 billion cubic feet of material ejected from Level 7 eruptions. Now let's add up the ejected material from both categories of eruptions. 5 billion plus 500 billion equals 505 billion cubic feet of material ejected during the simultaneous eruptions. This amount of material would cover a significant portion of the Earth's surface. Assuming an average thickness of 3 feet, it would cover an area of approximately 168,000 square miles. To put this into perspective, this is roughly equivalent to the size of Pennsylvania and Delaware combined. In addition to the material covering the Earth's surface, these eruptions would also inject a substantial amount of ash and gases into the atmosphere. Ash would blanket large parts of the planet, blocking sunlight and causing darkness even during the day. Sulfur dioxide and other gases would react with water in the atmosphere to form sulfuric acid aerosols. These aerosols would reflect sunlight back into space, leading to a prolonged period of global cooling. The combined effects of the ash and gas emissions could trigger significant disruptions in global weather patterns, ocean currents, and ecosystems. Agriculture would be devastated due to the lack of sunlight and soil contamination from volcanic material. Food shortages and widespread famine would likely follow. In addition to the physical impacts, this event would likely have profound psychological effects on humans and other animals. The sudden darkness and eerie daytime skies could lead to widespread panic and distress. Disruptions in food supply chains and infrastructure could lead to societal breakdown and mass migration. It's important to note that this is a simplified model, and the actual impacts of such an event could be much more complex and severe. The sequence of events described above highlights just how devastating a large-scale volcanic eruption can be. While such events are rare, studying them helps us better understand the risks and prepare for similar events in the future. So what would happen if every volcano on Earth erupted? Our planet could survive a series of massive volcanic eruptions, but it would undoubtedly face catastrophic consequences. The sky would be filled with ash, blocking sunlight and plunging the Earth into darkness. Global cooling, food shortages, and widespread ecological damage would likely follow. But life somehow always seems to find a way to adapt and recover, even in the face of the most extreme challenges. Not all volcanoes are created equal. Some are gentle giants that ooze lava slowly, while others explode with deadly force. The impact of a volcanic eruption depends on where and how it happens. A volcano that erupts underwater won't affect us as much as one that blasts high into the air. For example, scientists use the Volcanic Explosivity Index to describe how explosive a volcano is. Some are so big they're called cataclysmic. Those are the ones we really need to watch out for. Volcanoes are fascinating and sometimes dangerous, but they're also part of what makes our planet so unique. So let's take a moment to appreciate them, whether they're bubbling away quietly or putting on a spectacular show. Remember to keep a safe distance. So many volcanoes, so little time. Did you learn nothing? Do you want more? Well then check out this video where we ask the question, can volcanoes kill you? Or binge on this playlist for more awesome videos? Just click here. And don't forget to subscribe. It's free and a great way to support our channel. Thanks for watching.